All right, we're going to finish this section. It's page 20. So remember our rules. We have the multiplication rule, where when we multiply the same base we add. Our quotient rule, we're subtracting. Our power to a power, we multiply powers raised to another power. Our negative exponents that flip over the fraction bar, and our zero exponents. We know all of these things, and now we're going to use these, but we're going to use fractions, okay? You guys will be just fine. If I change the square root of x to a fractional exponent, I get x to the 1/2 times this one, I get x to the 1/3. Okay, this is multiplication rule. So I have x to the 1/2 plus 1/3. Now, I know many of you have trouble with fractions and adding them. We cannot add them the way that they are. Check these with your calculator. Okay, we need a common denominator. So I can multiply this by 3, x to the 3/6 plus this times to the second. So now I get 2/6. Now I can add these. My answer is x to the 5/6. Again, your calculator will do it for you, so don't really worry, but I don't have a calculator on me. Now I'm going to change this k, so it's going to be k to the 5/2, right, because that's a square root, times k. I'm going to do the inside first to show you how this works. This is k to the 1/2. That's all inside, and then we still have that 3 on the outside. Well, you can see that we're raising a power to a power. When we raise a power to a power, we multiply. So this k to the 5/2 stays the same, and this is now k to the 1/2 times 3. If you're not that good with fractions, make sure you use your calculator, but when we multiply, we just multiply straight across. So this is k to the 5/2 times k to the 3/2. Now I can use my multiplication rule where I multiply the same base, I add exponents. This gives me k, and since I have a common denominator, when I add them I get 8/2. Well, 8 divided by 2 is just 4, so k to the 4th. That's simplified really nicely. Now I can see that I'm dividing. I'm going to change these first. G to the 1/2, right? 1 over 2 over g to the 1/3. Now I have to do subtraction. So g to the 1/2 minus 1/3, right? When I divide the same base, I subtract exponents. And just like on this one up here, I'm going to convert them into sixths. So I can subtract. I'm going to multiply this by 3. So I get g to the 3/6 minus, multiplying this times 2, minus 2/6. And this subtraction is g to the 1/6. Now if I wanted to be cool and put it back into a radical, I could do that. I could call this g to the 1st, and my radical, it's a 6th root. Okay, so we don't have to go just backwards, we could go forwards and backwards, but both answers are fine. Now in this one, same thing, I'm going to convert p to the 7/2 divided by p to the 3/2. So when I divide the same base, I can subtract exponents. This is p to the 7/2 minus 3/2, right? That's all the same. Again, you can use your calculator if you want, but this has a common denominator of 2, so I could subtract p to the 4/2, which simplifies. 4 divided by 2 is 2, p squared. We want to simplify as far as we can, so we've got a lot to look for. Okay, good luck. This shouldn't be too hard because it's connecting all the stuff that we already learned with the radicals, and then we're going to start doing more with just radicals.